Tonight, we turn our attention towards something you do every single moment of your waking life, without ever being asked to. What does it mean to trust a memory that your brain may have quietly rewritten while you slept? Science tells a gentler story than most people expect, and that story begins right here, with you, exactly as you are. Welcome to Psychology for Sleep. Wherever you are, right now, perhaps with the lights already low, that particular softness settling into the room around you, allow yourself this kind of stillness. We'll trace through 100 relaxing facts about false memories and the subconscious mind, from the moment a memory first forms and already begins to change, to the tender science of why your brain rewrites the past, to the quiet freedom waiting on the other side of understanding. These quiet explorations of the mind create a sanctuary for people who have always felt something was slightly off about a memory, but never knew why. A soft like, subscribe, or share could help another searching mind find their way here too. Someone out there is lying awake tonight, quietly doubting a memory they have carried for years. This might be exactly what they needed to hear. Let yourself settle completely here. Feel your jaw unclench, your shoulders drop. Notice how the tension of the day begins to soften, like a room after the last guest has gone. Still, unheld, and finally, only yours. You don't need to hold on to any of this tonight. Just let yourself be present. Close your eyes and breathe deeply. You're resting where quiet rooms hold the most. Let your mind soften there. And now we begin. Memory does not work the way most of us believe. For much of human history, the brain was imagined as a kind of archive, a library where experiences were stored intact and retrieved when needed. Entire legal systems were built around this idea. The testimony of an eyewitness was considered among the most reliable forms of evidence a courtroom could receive. But research over the past 4 decades has fundamentally changed that understanding. Memory, it turns out, is not a recording. It is a reconstruction, an active, creative process that happens fresh each time you remember something. The brain doesn't simply play back what happened. It rebuilds the experience from fragments, filling in gaps with logic, expectation, and feeling. Tonight, we begin exploring what that means. Every time you recall a memory, you are not accessing a static file. You are rebuilding it from scratch, using pieces stored in different regions of your brain. The hippocampus, a small curved structure tucked deep in the temporal lobe, plays a central role in assembling these pieces. But the visual details come from the visual cortex. The emotional tone comes from the amygdala. The sense of context, where and when, is coordinated by the prefrontal cortex. Each retrieval is a collaborative reconstruction, and because these regions don't always communicate perfectly, the assembled memory is never quite identical to the original experience. Small things shift, details blur, new information quietly enters, and the brain accepts the result as true. The technical term for the brain's vulnerability to memory alteration is the misinformation effect. It was first formally described by psychologist Elizabeth Loftus in the 1970s, and it has since been replicated hundreds of times in laboratories across the world. In her original studies, Loftus showed participants footage of a car accident and then asked them questions that contained subtle false details. referring to a stop sign when there was actually a yield sign, or asking how fast the cars were going when they smashed versus when they hit each other. Those who heard the word smashed consistently estimated higher speeds and were more likely to later report seeing broken glass that was never in the footage. A single word was enough to reshape a memory. The misinformation effect is not a sign of a damaged or weak mind. It is a fundamental feature of how human memory is built. Researchers have now documented it across virtually every age group, cultural background, and cognitive profile studied. Children show it. Adults show it. Older adults show it. People with above average intelligence show it at rates comparable to everyone else. High confidence in a memory does not protect against misinformation. In some studies, the most confident witnesses were also among the most susceptible to subtle suggestion. The feeling of certainty, it turns out, tells us relatively little about the accuracy of what we are certain about. Knowing this is not unsettling. It is, in a quiet way, freeing. False memories are not fabrications in the ordinary sense. They do not feel invented. They feel exactly like real memories. Vivid, emotionally resonant, specific. This is one of the most disorienting aspects of memory research, and also one of the most important. When laboratory participants are later told that a memory they reported was actually implanted through suggestion, many of them resist the correction. They insist the event happened, not because they are being deceptive, but because the brain has accepted the reconstructed memory as authentic. The phenomenology, the internal experience of the memory, is indistinguishable from genuine recollection. The brain cannot easily tell the difference, and in most moments of daily life, neither can the person doing the remembering. One of the most replicated findings in false memory research is the DRM paradigm, named for researchers Deese, Rudiger, and McDermott. In these experiments, participants are read long lists of words, all related to a central theme, like sleep, pillow, rest, night, blanket, dream, tired, bell. But the central word itself, asleep, is never read aloud. When participants are later asked to recall the list, the majority confidently report hearing the word sleep, often with higher confidence than words that were actually presented. The brain filled in the gaps so efficiently, so naturally, that it became indistinguishable from genuine experience. The missing center was invented by expectation, and the invention felt true. The subconscious mind plays an active role in this process of memory construction. While conscious attention focuses on what is explicitly presented, the words spoken, the events witnessed, the subconscious is simultaneously processing patterns, association, and predictions. It anticipates what should be there based on what usually is, and when the actual input is ambiguous or incomplete, the subconscious fills the space with the most statistically likely answer. This is not a malfunction. It is efficiency. The brain cannot store a perfect copy of every experience. Instead, it stores compressed fragments and relies on intelligent reconstruction to complete the picture. The cost of that efficiency is occasional and completely involuntary. Inaccuracy. Sleep itself plays a profound role in the formation and consolidation of memory. During non-REM sleep, particularly the slow-wave stages that dominate the early part of the night. The hippocampus replays the events of the day, transferring selected information to the cortex for long-term storage. But this process is not passive. The brain curates. It selects which memories are worth keeping, which can be compressed, and which can be released. During this curation, memories are also integrated with existing knowledge, connected to what the brain already knows. And in that integration, small adjustments are made. The stored version of an experience is already a slightly edited version by the time morning comes. The role of emotion in memory is both protective and distorting. The amygdala, the almond-shaped region of the brain closely associated with emotional processing, tags experiences with emotional significance. High emotion events are flagged as important and prioritized for consolidation. This is why traumatic or joyful events tend to feel more vivid and lasting than neutral ones. But emotional intensity does not guarantee accuracy. Research consistently shows that while emotional memories are more detailed in some respects, particularly the central elements of the experience, peripheral details are often more distorted than in neutral memories. We remember the feeling with clarity, the surrounding facts less so. So here, 10 facts in, we arrive at the first signal of what tonight's journey is building toward. The brain does not remember the past. It reconstructs it, shaped by emotion, expectation, suggestion, and sleep. What you trust as memory is, in a very real sense, a living document. It has been quietly edited by every moment between the original experience and now. This is not a failure of your mind. It is the architecture of a brain designed for learning and adaptation rather than perfect archival. The question the science is leading us toward is not whether your memories are accurate. It is what that reconstruction reveals about who you are and who you are becoming. The concept of source monitoring is central to understanding why false memories feel real. Source monitoring refers to the brain's process of tracking where a memory came from, whether something was actually experienced, imagined, read about, or told by someone else. When source monitoring works well, the brain correctly identifies the origin of a memory. When it fails, and it fails more often than most people realize, internally generated thoughts or externally provided information can be mislabeled as direct experience. A vivid daydream can later feel like a real event. A story told about your childhood can be absorbed into your own first-person narrative. The source is forgotten. The content remains. Wearing the texture of experience, children are particularly susceptible to source monitoring errors, but not because they are less intelligent or less reliable. It is because the prefrontal cortex, the region most responsible for source monitoring, is among the last areas of the brain to fully develop. It continues maturing well into early adulthood, sometimes into the mid-20s. This means that early childhood memories are reconstructed with less reliable source tracking than memories formed later in life. It also helps explain why it is possible to absorb family stories, photographs, and repeated retellings of early events into what feels like genuine personal memory, when in fact, the original experience may be entirely inaccessible or may never have been encoded at all. One of the most striking demonstrations of how easily autobiographical memory can be altered comes from what researchers call the lost in the mall paradigm. In these studies, participants were told by a trusted family member that they had been lost in a shopping mall as a small child. The event never happened, but participants were given a short, written description of the incident alongside 3 genuine childhood memories, and were asked to recall details over a series of interviews. In the original studies by Elizabeth Loftus and her colleagues, a notable portion of participants, roughly 1 in 5 to 1 in 4, depending on the iteration, came to report some recollection of the false event. Later analysis has refined how these findings are interpreted, but the underlying pattern has held. Suggestion from a trusted source, combined with the imaginative acts of remembering, can generate something that feels like genuine recall. More recent research has explored more complex forms of false memory, including fabricated events involving confrontation, loss, or even minor transgressions. Some of these studies, using structured interviewing techniques, found that a meaningful portion of healthy adults came to partially accept the suggested events as genuine after repeated suggestion. Estimates of susceptibility vary widely across study designs, and researchers continue to refine how best to measure and interpret these findings. What is consistent is that the same ordinary processes of memory, pattern completion, expectation, and the passage of time are sufficient to create experiences that feel real without being accurate. The implication is not that people are gullible or weak-minded. The implication is that the human memory system was never designed for courtroom-level accuracy. It was designed for something else entirely. The purpose of memory, from an evolutionary perspective, appears to be less about preserving the past and more about guiding the future. Memory researcher Donna Rose Addis and neuroscientist Daniel Schachter have proposed and gathered substantial evidence for what is called the constructive episodic simulation hypothesis. This framework suggests that the same neural machinery used to reconstruct past experiences is also used to simulate future ones. When you imagine a meeting that hasn't happened yet, a conversation you're dreading, or a place you've never been, you are using your memory system in exactly the same way as when you recall the past. The brain is a simulation engine. Memory is its raw material. This link between memory and imagination, between the past and the simulated future, is visible in brain imaging studies. When participants in functional MRI scanners are asked to remember a specific past experience and then asked to imagine a specific future event, the same network of brain regions activates in both cases: the hippocampus, the medial prefrontal cortex, the posterior cingulate cortex, the lateral temporal cortex, all light up with striking similarity during both tasks. The brain, it appears, does not treat memory and imagination as fundamentally different operations. They are variations on a single cognitive capacity, and understanding this changes how we understand both. People who suffer damage to the hippocampus through injury, illness, or certaines conditions often lose not only the ability to form new memories, but also the ability to imagine future events in any coherent, detailed way. A patient known in the literature as KC, who suffered extensive hippocampal damage in a motorcycle accident, could not remember autobiographical events from his past and, when asked to imagine what he might do tomorrow, reported a complete mental blank, not a lack of willingness. a genuine absence of any content. The future, for him, had become as inaccessible as the past. Memory and imagination, it turned out, relied on the same architecture. The relationship between the subconscious and false memory is not simply passive. The subconscious mind actively shapes what gets remembered and how, during sleep. One of the most important functions of the subconscious is what researchers call active systems consolidation, a process in which the sleeping brain reactivates, evaluates, and selectively strengthens certain memories while allowing others to fade. But the selection criteria are not purely factual. Emotional relevance, predictive value, and connection to existing beliefs all influence what is kept and how it is kept. The version of a memory that survives sleep is not a neutral recording. It is a version already shaped by what the brain believes you need. One of the quieter implications of false memory research is what it reveals about the reliability of our self-concept, the narrative we carry about who we are, our identity, our history, our defining experiences, is built almost entirely from memory. And if memory is a reconstruction, then identity itself is, in some meaningful sense, a reconstruction too, not a fixed archive of a real and settled past, but an ongoing story that the brain keeps editing in response to new experiences, new information, and the changing emotional needs of the person living it. This is not destabilizing. When understood gently, it is, in fact, one of the most hopeful things neuroscience has found about the human mind. The therapeutic implications of memory's reconstructive nature are significant and actively being explored. If memories can be altered by suggestion and new information, then traumatic memories, which often loop with remarkable persistence, may be more accessible to change than previously believed. Research in memory, reconsolidation, a process by which retrieved memories become temporarily malleable before being restored, has opened a new area of investigation into conditions like post-traumatic stress. Studies suggest that during the brief window after a traumatic memory is recalled, it may be possible to introduce therapeutic interventions that soften the memory's emotional charge, not by erasing it, but by updating the emotional context in which it is held. Memory reconsolidation was first documented clearly in animal studies in the late 1990s and early 2000s, and has since been investigated extensively in human participants. The basic finding is this: when a long-term memory is retrieved, brought back into conscious awareness, it temporarily returns to a labile or unstable state. During this window, the memory requires restorage, and in that process of restorage, new information, including the emotional context of the present moment, can be incorporated. The memory is updated before it is stored again. This is why revisiting an old hurt in a safe, calm environment can, over time, genuinely change how that memory feels. Not just how you think about it, but how it registers in the body. The subconscious mind is particularly active in processing emotionally significant memories during the REM stages of sleep. Research using detailed sleep monitoring has shown that REM sleep is associated with a unique neurochemical environment. During REM, norepinephrine, a stress-related neurochemical, is largely absent from the brain. Researchers, including Matthew Walker at the University of California, Berkeley, have proposed that this norepinephrine-free environment allows the brain to reprocess emotional memories in a calmer state. The content of the memory can be replayed and integrated without the full stress response that accompanied the original experience. Sleep, in this framework, is a kind of built-in emotional therapy. It does not erase what happened. It changes how it is held. This is one of the reasons that sleep deprivation is associated with heightened emotional reactivity and difficulty processing difficult experiences. When the REM stage is cut short, whether by an alarm, by substances that suppress REM, or by fragmented sleep, the emotional processing that would normally occur during the night is interrupted. Memories that needed reprocessing are stored without the softening that REM provides. The next day, those memories can feel rawer, more activating, more difficult to hold at any distance. Over time, chronic sleep deprivation appears to interfere not only with how new memories are formed, but with how older, emotionally charged memories are gradually integrated. Rest is not an interruption to memory work. Rest is part of the work. One particularly intriguing aspect of false memory research is what is called imagination inflation. The finding that simply imagining an event increases the likelihood that a person will later believe it actually occurred. In experiments conducted by Gary, Manning, Loftus, and Sherman, participants were asked to rate their confidence that certain childhood events had happened to them. They were then asked to imagine some of those events vividly. When tested again 2 weeks later, participants who had imagined an event reported higher confidence that it had occurred in real life, even for events rated as unlikely before the imagination task. The act of imagination alone was enough to elevate belief. The brain experienced the simulation as a trace of reality. 25 facts in Nomblist. A pattern is emerging that the science is building toward throughout this journey. Memory is not a record of what happened. It is the brain's best current hypothesis about what happened, updated regularly, shaped by emotion, suggestion, sleep, and imagination. The memory you carry of your childhood, your relationships, your defining moments, has been quietly revised many times since the original experience, not through deception, through the ordinary, continuous work of a brain that is always learning, always adapting, always trying to build a story that makes sense of the past in the context of the present. That revision, that ongoing authorship, is not a flaw. Tonight, we will discover what it truly is. Let's pause here and notice your body as you breathe out slowly. Appreciate each tiny cell inside. Your brain has been working since you woke this morning, sorting, comparing, predicting, remembering. Right now, in this quiet, it is still tending to you, deciding what matters, releasing what doesn't. You don't need to do anything with that. Notice the gentle weight of your body where it rests, the warmth of the surfaces beneath you. Your nervous system knows how to do this. It has known for your entire life. Now we continue. The concept of the subconscious mind predates modern neuroscience by more than a century, but the scientific picture has become considerably more nuanced than the cultural image most people carry. The subconscious is not a hidden basement of repressed desires, as it was sometimes depicted in early psychological theory. It is More accurately, the vast majority of brain processing that occurs below the threshold of conscious awareness, automatically, continuously, and with remarkable sophistication, estimates vary. But a widely cited figure in cognitive neuroscience suggests that conscious processing accounts for a small fraction of total brain activity at any given moment. The rest is happening without your attention and without your knowledge. Priming is one of the most studied and most reliable demonstrations of subconscious influence on memory. In priming experiments, exposure to a stimulus, a word, en image, a sound, affects how a person responds to a later, related stimulus, without the person being aware that the first stimulus had any influence. For example, briefly seeing the word nurse, even too quickly to consciously register, makes a person faster and more accurate in recognizing the word doctor shortly afterward. The subconscious mind has noted the association and prepared the brain for what statistically tends to follow. Memory and perception are constantly being shaped by patterns the conscious mind never notices. One of the most significant contributions to false memory science in recent years has come from the study of what researchers call spontaneous false memories. Memories that arise without any deliberate suggestion or external pressure. These emerge from the brain's ordinary pattern completion processes. When you witness a complex event, the brain stores it in compressed, gist-based form, rather than as a detailed recording when you later retrieve that memory. The brain completes the gist using stored knowledge about how similar events typically unfold. This works well the vast majority of the time, but occasionally, the completed version includes details that were part of the expected pattern. Rather than the actual event, the brain chose the likely over the literal. Individual differences in susceptibility to false memories are a growing area of research. Some people show higher rates of false memory formation than others in laboratory settings, and researchers have been investigating what underlies these differences. One factor is what is called dissociativity, a trait describing how readily a person can become absorbed in internal mental experiences. Individuals who score higher on measures of absorption tend to show higher rates of false memory formation in some study designs. This is not a pathology. Absorption is also associated with richness of imagination, depth of empathy, and the capacity for deep aesthetic experience. The same trait that opens a person to vivid imagining may also open them slightly to imagining as remembering. Sleep quality appears to influence susceptibility to false memories in ways researchers are still characterizing. Several studies have found that sleep-deprived participants show higher rates of false memory endorsement than rested participants in tasks like the DRM paradigm. One proposed mechanism involves the reduced availability of prefrontal cortical resources after sleep deprivation, resources that normally help the brain maintain careful source monitoring and distinguish what was actually experienced from what was only related. When those resources are reduced by fatigue, the brain's gist-based processing takes over more completely. The general patterns feel true. The specific origins become harder to trace. Sleep, it seems, is not only the time when memories are consolidated, it is also when the conditions for accurate remembering are restored. The emotional content of a memory influences not only how strongly it is encoded, but how thoroughly it may be updated on each retrieval. Research into memory reconsolidation has shown that highly emotional memories, when retrieved, appear to undergo this reconsolidation process more robustly, making them both more accessible to therapeutic intervention and, in some cases, more responsive to the emotional context present at the time of recall. This is meaningful in a gentle way. It suggests that the memories carrying the most weight are also, in a structural sense, the most capable of being softened, not erased, but gradually integrated, particularly when revisited in conditions of safety, calm, and rest. The phenomenon of flashbulb memories illustrates the gap between confidence and accuracy with particular clarity. Flashbulb memories are the vivid, detailed memories people form of highly significant events. Where they were, what they were doing, who told them. When learning of something that carries profound, personal, or collective significance, these memories feel exceptionally clear and permanent. Research following major public events has tracked participants' memories over years and found that while confidence in these memories remains very high across time, the accuracy of specific details declines substantially. People feel certain that details have changed. The feeling of clarity is not evidence of clarity. Gender differences in false memory susceptibility have been studied with mixed and evolving findings. Some research has suggested that women may show slightly higher rates of false memory formation in certain paradigms, which some researchers have linked to higher average scores on measures of absorption and imagery vividness. Other researchers have noted that these differences, when they appear, are small and highly context-dependent. There is no established evidence that one gender has fundamentally less reliable memory than another. What the research does suggest is that the personality traits associated with higher false memory rates, including imaginative absorption and emotional sensitivity, are distributed across individuals in complex ways that do not map neatly onto any single category. Aging affects memory in ways that are often misunderstood. Older adults do show higher rates of certain types of false memories, particularly those arising from gist-based processing and source monitoring errors. But this is not simply a story of decline. Research also shows that older adults are often better at extracting the meaningful gist of an experience. The central themes, the emotional significance, the broader pattern. While becoming less focused on peripheral details, this shift in cognitive style reflects an adaptation rather than a pure loss. The aging brain trades some precision for greater integration. It becomes, in a meaningful sense, a more experienced storyteller, even as the specific details of stories become less reliable. The relationship between stress and memory accuracy is one of the most practically important areas of false memory research. Acute stress, the kind produced by a genuinely threatening or overwhelming experience, activates the release of cortisol and adrenaline, which have complex and sometimes opposing effects on memory. At moderate levels, stress can enhance the encoding of the central, emotionally significant elements of an experience. At high levels, stress appears to impair source monitoring and increase susceptibility to misinformation. This means that the experiences most likely to become significant memories, highly stressful ones, are also the experiences most likely to carry some distortion from the conditions under which they were formed. The therapeutic approach, known as eye movement desensitization and reprocessing, or EIM, EMDR is one of the most studied psychological treatments for trauma and is recognized as effective by major health organizations worldwide. While its precise mechanism is still studied and debated, one framework connects EMDR to the memory reconsolidation process. During EMDR, traumatic memories are retrieved and held in working memory while the client performs bilateral sensory stimulation, typically tracking the therapist's moving finger. Some researchers propose that this process allows the traumatic memory to enter the reconsolidation window in a context of relative calm, enabling new, less distressing emotional associations to be incorporated into the stored memory. The memory is not erased. Its emotional texture is gently updated. The legal system's relationship with memory evidence has changed substantially as false memory research has accumulated in many jurisdictions. Forensic interviewing protocols have been revised to reduce the risk of inadvertently introducing false memories through leading questions, repeated questioning, or suggestive feedback. The cognitive interview, a structured approach to witness questioning developed by Ronald Fisher and Edward Geiselman, was specifically designed to enhance accurate memory retrieval while minimizing the conditions that produce false memories. It encourages witnesses to reinstate mental context, report everything without editing, and approach the memory from multiple temporal directions. Accuracy is not simply a matter of trying harder. It is a matter of creating conditions that support genuine reconstruction. One of the more counterintuitive findings in memory science is that trying too hard to remember something accurately can increase the likelihood of false memories. In conditions of high retrieval pressure, when a person feels urgency, expectation, or significant stakes attached to remembering correctly, the brain's gist-based processing tends to become more dominant. The drive to produce an answer overrides the careful source monitoring that normally governs what gets accepted as genuine. This is one reason why memories retrieved under conditions of strong suggestion are considered unreliable as legal evidence. Not because suggestion accesses a different layer of memory, but because the pressure of the context amplifies the brain's tendency to confabulate. More effort in memory can sometimes mean less accuracy. The study of false memories has also revealed something important about the nature of belief. When people are exposed to misinformation that fits their existing worldview, their beliefs about themselves, others, or the world, they are more likely to accept and retain that information as genuine memory. Confirmation bias, a well-documented cognitive tendency, extends into the memory system. The brain is more likely to preserve memories that fit the story it is already telling about itself, and more likely to allow discordant memories to fade or be reframed. This is not a moral failing. It is the brain's attempt to maintain a coherent and functional narrative of the self, but it is worth noticing, gently, without judgment, when it is happening. 40 facts in. The evidence has been building from multiple angles. Memory is reconstructive. The subconscious shapes what is kept and how. Stress, sleep, emotion, suggestion, belief, and the passage of time all leave their marks on the memories we carry. And the system that produces false memories is the same system that allows us to imagine the future, process difficulty, maintain identity, and hold a coherent story of who we are across a lifetime. There is no version of human memory that is simply accurate and another that is simply false. There is only memory, a living, adaptive, imperfect, and remarkably purposeful process. And tonight, we are only halfway through what it wants to tell us. You're still here, still listening, still somewhere between thinking and resting. Take one slow breath. Your brain is doing exactly what it was built to do tonight. Not filing facts, not making records, building something softer and more useful than records. We'll keep going together, gently. The neuroscience of confabulation, a condition in which people produce false memories without any intent to deceive, offers one of the clearest windows into how memory is constructed rather than retrieved. Confabulation occurs in certain neurological conditions, including Korsakoff syndrome, following some brain injuries, and in some forms of dementia. People who confabulate produce detailed, internally consistent, and deeply believed accounts of events that never occurred. They are not lying. The brain's memory reconstruction system is operating without its normal error-checking mechanisms. The result is a vivid, confident, completely invented memory that feels entirely genuine to the person holding it. It is memory without the anchor of the original event. What confabulation reveals is that the brain's narrative-generating system is robust and active, always ready to produce a story. Even when the underlying material is absent or incomplete, this system is not a flaw. In ordinary life, it is what allows memory reconstruction to happen fluidly and quickly, producing a usable account of the past without requiring perfect recall of every detail. The problem in confabulation is not that the system is generating narrative. It is that the checks on that narrative have failed. The lesson for understanding ordinary memory is that the checks are always in play, but they are imperfect, and they can be influenced by fatigue, emotion, suggestion, and the conditions under which retrieval happens. The question of whether it is possible to distinguish true memories from false ones has been investigated using brain imaging. Research suggests that true memories and false memories activate overlapping but not identical patterns of brain activity. True memories tend to show activity in sensory regions: the visual cortex, the auditory cortex. These areas hold the genuine texture of what was actually seen and heard. False memories show less activity there, and more in regions associated with semantic processing, meaning, and conceptual knowledge. The difference is subtle and cannot be reliably detected in individual cases, but at a group level, the brain leaves different traces on what was experienced and what was only reconstructed. The relationship between narrative and memory is one of the more philosophically resonant areas of this research. Human beings are deeply narrative creatures. We do not experience our lives as a collection of disconnected moments. We experience them as stories, with continuity, causation, to theme, and meaning. Memory is the raw material of personal narrative. And personal narrative, research suggests, actively shapes memory in return. The stories we tell about ourselves, to others, influence which memories we return to, how we frame them, and over time, how we store them. The self is not simply the narrator of memory. It is also its editor, its curator, and, in quiet ways, its author. One of the more intriguing recent lines of research concerns what is called the self-memory system, a theoretical framework describing how personal memories are organized and maintained in service of the self. According to this framework, memories exist at multiple levels of specificity, from general lifetime periods to life events, to specific event details. The self acts as a kind of curator, maintaining the coherence of the memory system by keeping certain memories accessible and allowing others to fade. Memories that are consistent with a person's current self-concept tend to be more accessible and more robustly stored. Memories that threaten self-coherence may be reframed, minimized, or gradually released. Memory is not neutral. It serves the person doing the remembering. The study of childhood amnesia, the near-universal inability to remember experiences from the first 2 to 3 years of life, offers another perspective on the subconscious and memory formation. Although the brain is actively encoding information from birth, the structures and networks required for explicit, autobiographical memory that can be consciously retrieved are not fully functional in infancy. The hippocampus, in particular, undergoes significant postnatal development. By the time the necessary structures are in place, the early experiences, which were encoded in different, more implicit ways, are not accessible to the adult retrieval system. They are not gone. They shaped development, influenced emotional patterns, contributed to who the person became, but they cannot be remembered in the ordinary sense. Implicit memory, memory that influences behavior and perception without conscious recall, is one of the most important and least discussed aspects of the subconscious. It includes procedural memory, knowing how to ride a bicycle, type, play an instrument, as well as conditioned responses, émotionnelle association, and the vast network of learned patterns that guide daily life below the level of awareness. Implicit memory is often called body memory in popular language, and while that term oversimplifies the neuroscience, it captures something real. The body does respond to experiences that the conscious mind cannot access, and those responses shape decisions, preferences, reactions, and relationships, continuously, quietly, and without announcement. One of the most significant recent advances in understanding the subconscious mind has come from research into the default mode network, a set of brain regions that become active during rest, daydreaming, mind-wandering, and self-referential thought. This network was initially viewed as background noise, activity that happened when nothing important was being done. But research over the past 2 decades has revealed that the default mode network plays central roles in autobiographical memory, future simulation, social cognition, and the construction of the self-narrative. What the brain does when it appears to be doing nothing turns out to be among the most sophisticated and identity-relevant processing it performs. The default mode network is particularly active during sleep, especially during the stages associated with dreaming. Dreaming appears to serve, in part, as the default mode network's most unfiltered expression, a space in which memory fragments, emotional residues, and self-relevant narratives are woven together without the constraints of external reality. Dreams have long been studied for their possible role in emotional processing and memory consolidation. Research supports the idea that the dreaming brain is not simply replaying the day, it is integrating the day's experiences with older memories, emotional patterns, and ongoing concerns in ways that have direct implications for how those experiences will be remembered and interpreted when waking life resumes. Halfway through this journey, the shape of the answer is coming into view. Memory is reconstruction. The subconscious is its architect. Sleep is its laboratory. And the false memories that emerge from this process, the invented details, the absorbed narratives, the confident recollections of experiences that unfolded differently than we remember, are not evidence of a faulty mind. They are evidence of a mind that prioritizes meaning over precision, adaptation over archival, and the ongoing coherence of the self over a perfect account of the past. The question we began with, what does it mean to trust a memory your brain may have quietly rewritten, is beginning to answer itself, and the answer is softer than most people expect. The memory you believe most strongly is actually reconstructed each time you recall it. Right now, your brain is rewriting itself, and tonight is part of that draft. Not a threat, a gift. Every time a memory is touched, by sleep, by reflection, by the quiet of a moment like this, it becomes slightly softer, slightly more integrated, slightly more yours. You are not the passive holder of a fixed past. You are its living author. Take a breath, and we continue from here. The experience of déjà vu, the uncanny feeling of having been somewhere or experienced something before, is thought to arise from a mismatch between the brain's familiarity signals and its recollection processes. The brain generates a sense of familiarity before completing the full process of identifying why something feels familiar. When familiarity fires without a matching recollection, when the feeling of recognition arrives without its source, the result is the strange, slightly vertiginous sensation of déjà vu. It is not a glimpse of a past life. It is a brief window into the ordinary architecture of memory. A moment when the brain's background processing becomes briefly visible. The opposite phenomenon, jamais vu, describes the equally uncanny feeling that something very familiar suddenly feels completely new and unfamiliar. Most people have experienced a version of this with words. If you repeat a common word aloud many times in rapid succession, it can begin to lose its meaning, its familiarity, its connection to any referent. The word sounds like sounds. This is sometimes called semantic satiation, and it is thought to reflect the temporary fatigue of the neural circuits responsible for connecting the word's form to its meaning. Familiarity, like memory itself, is not a fixed property. It is an active construction that requires ongoing maintenance. Research into the relationship between memory and identity has found that people who are asked to recall positive autobiographical memories show changes in mood, self-esteem, and sense of personal continuity. Even when the recalled memories are brief or mundane, the act of remembering who you have been appears to stabilize who you are. This finding has practical implications for well-being research. Some therapeutic approaches have explored the deliberate recall of positive autobiographical memories as a way of supporting psychological resilience, particularly in individuals experiencing depression or identity disruption. The memory system is not only a record of the past, it is an active resource for the present. Memory and attention are intimately linked in ways that are easy to underestimate. What enters long-term memory is, in large part, determined by what attention selects at the moment of encoding. Unattended information, things present in the environment, but not the focus of conscious processing, may leave traces, but is unlikely to be consolidated into durable memory. This is why multitasking impairs memory formation. It is why meaningful conversations remembered years later were conversations during which genuine attention was given. Presence, in the most literal, neurological sense, is a prerequisite for memory. What you attend to becomes part of your story. What passes unnoticed tends not to the hippocampus, long understood as central to memory formation, is now known to play an equally important role in spatial navigation. Studies of London taxi drivers, who must memorize an extraordinarily complex urban map, have found measurable differences in hippocampal volume compared to non-taxi drivers, with those who have driven longest showing the greatest differences in certain hippocampal subregions. This finding, first published in 2000 and subsequently replicated and extended, is considered one of the clearest demonstrations of structural neuroplasticity in the adult human brain. The brain physically changes in response to sustained cognitive demands. Memory and navigation share their roots in the same structure, and that structure is responsive to how it is used. One of the intriguing areas of current memory research concerns the possibility of targeted memory enhancement during sleep. Sleep science researchers have explored whether gentle acoustic stimulation during slow-wave sleep, soft sounds, timed to synchronize with slow oscillations in brain activity, can enhance memory consolidation. Early results have been promising. This is a developing field of investigation, still in early stages, exploring whether the conditions that support memory during sleep might be deliberately and gently optimized. The edges of what is possible are being quietly extended. The concept of memory traces, or engrams, has moved from theoretical abstraction to laboratory observation over the past 2 decades. Neuroscientist Susumu Tonegawa and his colleagues at MIT have demonstrated in animal models that specific memories can be traced to particular constellations of neurons, cells that were active during an experience, and that, when artificially reactivated, produce behaviors consistent with the original memory. More recent work has pushed toward identifying engram cells in human neural tissue and understanding how these cells are organized, maintained, and occasionally lost. A memory, at the cellular level, is a pattern, and patterns, unlike recordings, are inherently vulnerable to change and reconstruction. The malleability of memory has implications for how we understand forgetting, a process that is often experienced as loss, but may serve functions that research is only beginning to appreciate. Forgetting is not simply the failure of memory to persist. It appears to be, in part, an active process, a clearing that allows new learning to occur without interference from outdated information. Research by Richard Morris, Michael Anderson, and others has explored what is called inhibitory forgetting, the brain's active suppression of memories that are no longer useful or that conflict with current needs. A mind that forgot nothing would be, in important ways, impaired. The capacity to let go may be as important as the capacity to hold on. The popular notion that memories are stored in a single specific location in the brain is largely inconsistent with what neuroscience has found. Memories appear to be distributed across networks of neurons. with different aspects of an experience stored in different regions and bound together by activity in the hippocampus and related structures. This distributed storage is one reason memory is resilient. Damage to one region does not necessarily destroy an entire memory. Though it may impair access to certain aspects of it, it is also one reason memory is reconstructive. Reassembling a distributed memory requires active coordination, and coordination, however efficient, is always capable of small imprecisions. 60 facts in, and the understanding that has been assembling through this journey is becoming something more than a collection of findings. Memory is not a storage system. It is a process, ongoing, adaptive, shaped by experience and expectation, and the continuous work of a mind that is always trying to make sense of being alive. The false memories embedded in that process are not aberrations. They are the visible traces of a system doing its best to maintain coherence, continuity, and the possibility of meaning in the life of the person who carries it. That understanding that memory serves life rather than recording it is the turn this journey has been building toward. The subconscious mind appears to continue processing information during the hours of sleep in ways that can result in creative insights and novel solutions upon waking. The phenomenon of sleeping on a problem, allowing the mind to work on it without conscious effort, has been documented in a number of experimental paradigms. Research by Ulrich Wagner and colleagues published in Nature in 2004 found that participants who slept between practice sessions on a mathematical task were significantly more likely to discover a hidden shortcut than those who remained awake. The sleeping brain reorganized information in ways that made the solution visible. Memory, during sleep, is not stored. It is digested. The false memory system has an unexpected but important relationship with creativity, the same cognitive processes that lead to false memories: pattern completion, associative activation, gist-based processing, are also the cognitive processes underlying creative thought. The capacity to draw unexpected connections between disparate concepts, to complete a partial pattern in an original way, to generate a narrative that goes beyond the given information. These capacities arise from the same neural machinery that occasionally produces a memory of something that never happened. Creativity and confabulation share a root. The artist and the unreliable narrator are, in some neural sense, working from the same place. The study of eyewitness testimony continues to reveal the practical stakes of memory's reconstructive nature. The Innocence Project, founded in 1992, has documented hundreds of cases in which wrongfully convicted individuals were exonerated through DNA evidence. Across these exonerations, eyewitness misidentification has consistently emerged as one of the most common contributing factors present in the majority of DNA-based wrongful convictions. These were not cases of deliberate dishonesty. They were cases of sincere, confident memory that the physical evidence showed could not have been accurate. The implications for how memory evidence is collected, presented, and evaluated in legal contexts are ongoing and important. The neuroscience of nostalgia, the bittersweet longing for a past experience, illuminates how memory and emotion collaborate to create some of the most powerful mental experiences human beings have. Nostalgia is not simply the recall of a past event. It is the experience of that recall through the emotional lens of the present moment. colored by what has been lost and what has changed. Research has found that nostalgic memories tend to be positive in overall emotional tone. Even when the original experience involved difficulty, the brain smooths the difficult edges of the past over time, retaining the emotional gist of warmth and connection, while allowing the sharper details of pain or frustration to fade. Memory, left to its own processes, is often quietly merciful. We now understand, with considerable clarity, that the subconscious mind is not a repository of the past. It is a living, active participant in every moment of the present. It shapes perception, guides attention, primes response, and constructs the memories that will become tomorrow's understanding of today. The false memories that occasionally emerge from this process are not betrayals. They are the traces of a system doing its best to maintain coherence, continuity, and the possibility of meaning in the life of the person who carries it. That understanding, that memory serves life rather than recording it, is the turn this journey has been building toward all along. The way memories are retrieved changes based on the emotional state of the retriever. A well-documented phenomenon called mood-congruent memory retrieval describes the tendency to more easily access memories that match the current emotional state. When a person feels sad, sad memories become more accessible. When a person feels calm, gentle memories rise more readily. This is not simply an observation about what comes to mind. It has physiological correlates. The neurochemical environment of different emotional states appears to facilitate access to memories encoded in similar conditions. This is one reason that the calm of a quiet evening, a night like this one, creates conditions in which gentler memories are more naturally present. Research into what is called memory specificity, the tendency to retrieve general, overgeneral memories rather than specific, episodic ones, has found connections to psychological well-being. Individuals experiencing depression or chronic anxiety often show a pattern of overgeneral memory retrieval, recalling broad categories of experience rather than specific moments. This overgeneral pattern is associated with difficulty in problem-solving, emotional processing, and the capacity to imagine specific positive futures. Therapeutic approaches that encourage the retrieval of specific positive memories, particular moments, particular sensory details, have shown benefit in reducing this overgeneral pattern. Specificity in memory is not a luxury. It appears to be a dimension of psychological health. The brain's capacity to form new memories does not diminish uniformly with age. Research has found that different memory systems age at different rates. Episodic memory, memory for specific personal experiences, does show age-related change, particularly for peripheral details and source information. Semantic memory, general knowledge about the world, remains relatively stable or can even continue to grow through much of adult life. Working memory, the capacity to hold and manipulate information in the moment, shows more consistent, age-related change. But the picture is not one of global decline. It is a shifting balance, some capacities changing, others remaining robust, and some areas of accumulated knowledge deepening with time. The phenomenon of cryptomnesia describes a form of unintentional creative borrowing in which a person generates what they believe to be an original idea, not realizing that they are actually reproducing something they encountered earlier and forgot. The original memory of the source has faded, but the content was retained and later retrieved without its attribution. It has been documented in creative context, a writer or composer producing work that closely resembles something they read or heard years earlier. With no conscious memory of the original encounter, it is not deception. It is source monitoring failure at the level of creative production. The idea feels new because its origin has been forgotten. The study of post-traumatic growth, the genuine psychological expansion that can occur following significant adversity, has increasingly focused on the role of memory in that process. One component of post-traumatic growth appears to be the gradual development of a new narrative around the difficult experience, not denial or erasure, but a reintegration of the memory into a larger story of the self that accommodates hardship without being defined by it. Memory reconsolidation, narrative reconstruction, and the emotional reprocessing that occurs during sleep all appear to contribute to this process. Growth is not the absence of memory. It is the transformation of what memory means. The capacity for what researchers call mental time travel, the ability to project oneself mentally into both the past and the future, is considered one of the distinctive features of human cognition. Other animals show evidence of episodic-like memory, remembering specific past events, but the human capacity to mentally inhabit a remembered past or an imagined future with full first-person experiential vividness appears to be particularly developed. This capacity rests on the same neural foundations as the false memory system, the hippocampus, the default mode network, the reconstructive processes of episodic memory. The ability to live imaginatively across time is inseparable from the occasional confusion of imagination with memory. Research on autobiographical memory has identified what is called the reminiscence bump, a phenomenon in which older adults show robust recall of events from their adolescence and early adulthood, roughly from ages 10 to 30. Events from this period of life are recalled in greater number and with greater subjective vividness than events from other periods, including more recent ones. Several explanations have been proposed. This period coincides with a high density of first experiences and life transitions, which are encoded more robustly. It is also the period during which personal identity is being actively formed, making those memories particularly relevant to the self-system. Who we were at the beginning of our adult story becomes the anchor of who we remember being. The language in which a memory was encoded can influence its later retrieval. Research with bilingual and multilingual individuals has found that memories formed in one language are sometimes more easily accessible when retrieved in that same language. This effect, called language-dependent memory, is thought to reflect the deep integration of language and the neural networks involved in encoding autobiographical memories. The emotional context of a language, whether it is associated with home, with childhood, with safety or displacement, also colors the memories held within it. Language is not simply a medium for describing experience. It is part of the architecture of the experience that is remembered. The role of social interaction in shaping memory is profound and systematically underappreciated. The stories we tell others about our experiences, and the stories others tell us about our shared past, actively influence what and how we remember. Research on social contagion of memory has found that exposure to another person's account of a shared experience can alter the listener's own memory of that event. Even when the two accounts differ, couple families, and long-term friends develop what researchers call transactive memory systems, collaborative memory networks in which each person partly relies on the other for access to certain stored information. Memory is not only individual, it is, in meaningful ways, shared. The question we began with tonight, what does it mean to trust a memory that your brain may have quietly rewritten, has been answered now. In its intellectual form, it means recognizing that trust in memory is not about accuracy in the photographic sense. It means understanding that the brain rewrites memory in service of something more important than a perfect record, in service of adaptation, of healing, of the ongoing coherence of a self that is always growing. You are not a flawed rememberer. You are a living editor, and the revision has always been in service of becoming. That understanding, held gently, is one of the most restful things the science of memory has to offer. Sleep doesn't come when you try to sleep. It comes when you stop trying. This is exactly that moment. Your brain has been holding today, organizing it, editing it, deciding what matters, and now, in this quiet, it is beginning to let the day go. You don't need to help. You don't need to review anything. The work of this night is already underway. Let go. Memory is not what happened. Memory is what the brain made of what happened. And that distinction, held gently, changes everything. The past is not a fixed country. It is a story that the mind keeps tending, keeps softening, keeps making usable. What you carry tonight as memory is the most recent draft of something that will continue to be written for as long as you are alive and remembering. The brain consolidates memory most effectively in the hours between midnight and early morning, the hours when REM sleep is most abundant. This is not accidental. The timing of sleep architecture appears calibrated to the rhythm of human life. The day's experiences are processed in the early night. The emotional residue is softened in the later night. Morning brings a mind that has, quietly and without your direction, done remarkable work. Sleep is not the pause between days. It is where each day becomes part of who you are. Every memory you have ever held has been touched by sleep. Every important experience, every defining moment, every relationship you carry as part of your story, the version of it you hold now, has passed through the laboratory of the sleeping brain at least once. Often, many times, the people you remember. If you remember through the softening filter of all the nights that have come between then and now, memory, in this sense, is always already a little gentler than the original. The subconscious mind does not rest during sleep. It shifts into a different mode of work, deeper, less constrained by the demands of waking attention. During this time, it connects things the waking mind held separate. It finds patterns across the texture of the day. It releases what can be released and strengthens what needs strengthening. What surfaces in the morning? Tu as solution, a clarity, a feeling of having processed something, is the work of a mind that was busy while the body was still. False memories are, in the gentlest possible reading, a form of creativity. They are the mind filling in the spaces of experience with the most plausible, most emotionally coherent possibility it can generate. The invented details of a reconstructed memory are not random. They are shaped by who you are, what you expect, what you believe, and what you need the past to have been. They are, in this sense, a portrait of the self, drawn in the act of remembering the most emotionally significant memories of a human life, the ones that feel most defining, most vivid, most certain, are also the ones most likely to have been reconstructed many times. They have been recalled, revised, retold, and restored through countless cycles of sleep and waking. What feels most solid in memory is, in the science of it, among the most deeply processed, in memory terms, does not mean distorted. It means integrated, woven into the fabric of the self. There is a particular mercy in the way memory softens difficult experiences over time, not erasing them, not denying them, but gradually releasing the sharpest edges of the pain while retaining the meaning. Research shows that this softening is real and measurable, not simply a matter of perspective, but a genuine change in how the memory is stored and activated. The brain, left to its ordinary processes, moves toward healing. It takes time, it takes sleep, but the direction is built into the architecture. The default mode network, that constellation of brain regions that activates during rest, during mind wandering, during the quiet between tasks, is also the network most associated with the sense of self. When the mind wanders, it wanders toward questions of identity and meaning. It returns, again and again, to the people and experiences that matter. This is not distraction. It is the brain tending to the central questions of a human life, using the raw material of memory to do so. The wandering mind is working. Research into what makes memories feel meaningful, rather than merely accurate, has found that emotional significance is the primary organizing principle. The memories that people report as most defining, most worth telling, most central to their sense of self, are not necessarily the most factually complete. They are the ones in which emotion was most present, in which the stakes felt highest, in which something changed in the person who lived through the experience. Meaning, not accuracy, is what memory is ultimately organized around. The brain's willingness to rewrite memory in response to new understanding is one of the mechanisms underlying personal growth. When a person encounters a new perspective, a conversation that reframes an old wound, a quiet night of reflection that allows a different story to take shape, the memories involved are not simply thought about differently. They are, in the process of reconsolidation, stored differently. New understanding is not just intellectual. In memory terms, it is physiological. The brain encodes the new version. The old version slowly loosens its grip. The feeling of a memory, the embodied, sensory sense of having been somewhere, having felt something, is generated in the moment of recall, not stored intact from the original experience. The brain recreates the sensory qualities of a memory each time it is retrieved, drawing on stored patterns to produce the feeling of vividness. This is why memories can feel intensely real, even when they are inaccurate. The feeling is real. It is happening now. The memory it is attached to may be a reconstruction, but the experience of remembering it is always completely genuine. The science of memory ultimately points toward a view of the human mind that is more generous than the one most people carry, not a system that should be accurate, and too often fails. Something more patient than that, a system that maintains a story across time, that adapts to new experiences, that releases what it can, and slowly, through sleep and reflection, moves toward peace. That is what memory is doing. Every night, without your guidance, sleep is the kindest thing the brain does for memory. It takes the day, with all its edges, its unresolved moments, its accidentales bruses, and works on it in the dark. By morning, the day has been metabolized, not forgotten, not eliminated, but processed, changed, made part of the ongoing story rather than a fresh wound. You do not have to direct this process. You only have to allow it. Lying down is enough. Letting go is enough. The rest happens without you. Memory, understood this way, is less a record and more a compass. It points toward what mattered, and what mattered shaped the direction of a life. So, what does it mean to trust a memory your brain may have quietly rewritten? It has already happened. Many times, for every memory you carry. And the result of all that quiet revision is not a less trustworthy version of the past. It is a version that has been integrated into who you are now. That can be lived with, that can be learned from, that can, in the best cases, be healed through. The rewriting was not a betrayal. It was a form of tending. You are not a flawed rememberer. You are a living editor. The neuroscience of gratitude and its relationship to memory has emerged as a meaningful area of research. Studies have found that practices of deliberate gratitude, attending to and reflecting on positive experiences, appear to increase the accessibility of positive autobiographical memories over time, not by suppressing the difficult ones, but by strengthening the traces of what was good. Memory is responsive to where attention is directed. A gentle, sustained attention to what has been meaningful tends, over time, to make the meaningful more available. The mind remembers what it returns to. The breath you are taking right now will become, in some form, a memory, encoded likely never consciously retrieved, but part of the pattern of this night, part of what the brain will sort and organize in the hours ahead. In the same way, this understanding that memory is reconstruction, that the brain is always editing toward coherence and healing, can become part of how you hold your own past, not as a verdict, as a living story that is still being written. The forgetting that happens during sleep is as important as the remembering. Research suggests that sleep selectively weakens the traces of unimportant or redundant information, clearing space for new learning. What fades during the night is not always what we would consciously choose to release, but the brain's selection process, guided by emotional significance, predictive value, and relevance to the self, tends in the direction of what serves the person going forward. Forgetting, understood this way, is not failure, it is maintenance. One of the quieter gifts of understanding memory is what it does to the relationship with regret. Regret depends on a confident account of the past, on a memory of what happened, what you chose, and what might have been different. If memory is reconstruction, and reconstruction is shaped by the emotional needs of the present, then the regret itself has been influenced by who you are now, not only by what occurred then. The memory of the past mistake and the memory of the road not taken are both drafts, held lightly, that understanding can take some of the weight from what was carried as certain. The last fact of this journey belongs to the question that the science, in its most honest and most human moments, cannot fully answer. If memory is construction, and identity is built from memory, and the self is the narrator of a story that is always being revised, then who is doing the remembering? Not a fixed observer looking back at a fixed past. Something more fluid and more alive than that. A process rather than a place. You are not a flawed rememberer. You are a living, breathing editor. And the revision has always been in service of becoming. That is what the brain has been doing, all along, on your behalf. And so, our quiet journey through memory and the subconscious mind comes to a gentle close. We began with a simple and quietly liberating discovery that in the DRM paradigm, the word sleep felt remembered with complete confidence by the majority of participants. Because it was so deeply expected, the brain filled in what it believed should be there. And we traveled through the research on memory reconsolidation, that brief window after every retrieval, when a memory returns to softness before being stored again, when the past becomes, for a moment, open. 2 moments, 2 different windows into the same truth. The past is not a recording. It is a story the mind keeps tending. And that, held gently tonight, is not frightening. It is freeing. The same forces shaping who you remember yourself to be are also, quietly and continuously, shaping who you are becoming. Memory tends toward coherence, toward meaning, toward what can be lived with and learned from. The brain does not remember in order to preserve the past. It remembers in order to make the future possible. You are not a flawed rememberer. You are a living editor. And tonight, in the stillness, the editing continues. In these final minutes, take the deepest breath you can, as deep as possible. Think about unity, of every thought you have had tonight, every memory gently visited, every moment of recognition or quiet understanding. The same mind that creates false memories also creates compassion, creativity, and the capacity to imagine a future different from the past. Let your entire being dissolve into the quiet that your particular kind of mind has been searching for all day. Prepare for deep sleep, no boundaries left, only peace. This gentle exploration of memory and the subconscious may have rested something you didn't know was heavy. The soft like or subscribe could carry that same quiet relief to another searching mind. Someone who has spent years quietly doubting a memory, without ever knowing why that doubt was entirely reasonable. One peaceful night, one living editor at a time. Whatever you have been turning over today, those half-formed thoughts, those moments you keep returning to, you don't need to carry them into sleep. They will still be there in the morning. Tonight, you belong only to yourself. You have traveled inward tonight. Through corridors most people never pause to notice. You touched the architecture of who you are and found it more fluid, more gentle, more forgiving than it seemed. You can allow these thoughts of memory to fade now, like the last image of a dream at dawn, present, then softer, then simply part of everything, leaving only the quiet, unheld calm behind. Let your breathing deepen. Let your body feel heavier, as if patient hands are sorting what you carried today and setting it down, and is simply holding you. If sleep comes, let it carry you the way consolidation does, not with force, but with quiet intention, into a realm where time and weight no longer matter. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, your memory will still be there, still tending, still weaving, still becoming. But tonight belongs to stillness. Rest well, sleepy soul, and remember, your mind is always rewriting toward the calm. Good night.